All right, finishing off chapter 6. I have a little bit of a GUI here for adding up numbers that you enter into a text box. And looking at it, I don't see anything that is protecting us from writing past the end of the array. So we have an array called total here, and it's got 4 elements. And it looks like there's a text box called department and another text box called contribution. I did start the recording, didn't I? Yep. So we pull out the department from one text box, and we pull out the contribution into the other, and then we just increment the array using the department number as our index. So they better only be entering numbers 1, 2, 3, and 4. If they entered 5 or anything like that, anything greater than 4, it would blow up. So that's not the coolest way to do it. And when I say that, what would we do to correct it? Well, we ought to limit them. We ought to pop up an error message or something if they enter an incorrect department. Even cooler would be to display, like, a radio button, checklist. Well, checkboxes are different than radio buttons. Let them choose it from a list on screen, either with a pull-down menu or, a set of radio buttons. We haven't learned how to do that yet, but we really ought to. All right, summary. We already know all this stuff, but we're going to cover it anyways. An array is a list of data items. All data items have to have the same type and the same name. If you use inheritance, you can do some slick stuff there to where you declare an array of your parent class, your superclass, and then store things of your subclass types in it, and then it looks like you're storing items of different types. So in C#, all arrays are objects of a class named system.array, so you get some methods attached to them. The power of arrays become apparent when you begin to use subscripts. So you have the subscripts. The values of the index can be from 0 up to the length -1. You can use for each to go through all the elements of the array without using subscripts. The drawback is that you can't change the values of the elements as you do that. You need a more traditional for loop in order to actually change the values. If you need to, you can rip through an array looking for a specific item, meaning that you're searching for it. You can create parallel arrays. Parallel arrays are when you have more than one array of the same length where the items are matched by their index values. Days of the week and then sales for each day, something like that. Binary search is an efficient method for for searching into an array, but it requires the data to be sorted, which you can do this. The sort method arranges the array items in ascending order. If you want them in descending order, you first call sort and then you call reverse. So reverse is the order of the items. You can do multi-dimensional arrays. There are types of multi-dimensional arrays. 2-dimensional arrays. Okay, why is it calling out 2 as opposed to 3? I don't know, because you have 2, 3, 4, 5, 6, 7, 8, 9. You can have as many dimensions as you need. I'm sure there's some upper limit. However, we typically think in terms of either 2 or 3 dimensions, right? If you have a 2-dimensional array, you allocate it like this with commas so that you can get out element, later on when you want an element, an element out of it, you use 2, 2 like that to get it out. Or you can declare jagged arrays. And jagged arrays are arrays where each row can be of a different length, in which case you actually treat it as though it were an array of arrays. So you allocate that like this, or you declare it. And so A normal two-dimensional array in this language, you declare like that. Jagged arrays, you declare like that. You could make a jagged array that was actually rectangular where every row had the same length. This is the syntax that you would be more familiar with using in C++ or Java, I believe. I don't recall seeing the comma syntax in those two languages. So once you declare your rectangular array, you separate your index values by commas. Once you declare your jagged array, you separate your elements, like this, 3 comma, not comma, 3 index 3, like that. So read up on jagged arrays. I'm not going to give you examples of those. Hit the book for them. I never really used jagged arrays in my experience as a programmer. If I had to do that, I probably would have used lists, made an array of lists, since an array, since a list is already thematically, something of 0 elements or more. All right. What I want to do now is to go back and look at the assignment that I had planned on doing the last time, which is where we open up a WPF application and make some changes to it. So if you look, there's a folder O, WPF application with arrays. Seem to be missing our I there. It's actually got a single array in it, I believe. So make that singular. There's a zip file that contains a project. You want to grab that zip file, download it, extract its contents, and then open the project that's contained with it with Visual Studio. So there's our attachment. No, what have I done there? WPF arrays.zip. There we go. All right, just extract that to where you like to extract your C++ projects. Excuse me, your C# projects. I'm making a folder called C# tutorial O. Wherever you normally place them's fine. Now I'm going to go and look for that file with Visual Studio. File, open project, and I believe we've confirmed that both the newest versions of Visual Studio and 12 or 13 can open it. So I'm going to go to my folder where I extracted it, C# tutorial 0. This one's being called short 9. That's from a previous numbering scale I used in another semester. All right, then look at your Solution Explorer. We will see that there's a main window, because it is a WPF application, with some source code. Let's go look at the window first. All right, if we look at it, it's got a little box on the screen with 5 slots in it, 5 text fields. And then it's got a randomize. Apparently we're going to be creating some random numbers and putting them there. And then it's got a save. As you save them, it's going to be doing something with this larger scrolling text box down here. Now let's go and look at the source code, and there should be comments in there about how we're going to change our app. So the little plus signs, we're going to declare a 2D array named TDA. You see how I opened up line 22. Declare a 2-dimensional array called TDA and an int called index. Well, okay, we didn't have to make that change, did we? Int to TDA. That's how we declared our 2-dimensional array. Now we're going to come down here, Apparently I had the answers in here. I didn't really quite mean for that to be the case. But at least I don't have the answers for the second one. So go down to about line 45 or so, and step 2 is allocate our array. We can do that. It's supposed to be 10 rows by 5. TDA for two-dimensional array. All right, so TDA is equal to new int, and now I specify that it's 10 rows by comma 5 columns. Now we have a blank array. By blank, I mean that those values have been initialized to 0. Unlike some languages where when you allocate things, you don't necessarily get zeros. You don't give safe data in there. Yeah, you get garbage. Alrighty, let's go down to section 3.
You might have to unpause the recording. I don't think you recorded.
Yeah.
Oh, sorry.
So, where'd section 3 go? Oh, there we go. Around line 54. Generate 5 random bytes. Store them into our consecutive text boxes using the next bytes method. All right, do we want to make a loop, or do we just want to hard code 5 different? I say we make a loop. For int I is equal to 0. What was our counter up there called? Index. I'm not going to mess with index. I'm going to use I. I is equal to 0. I is less than the length of our array. I'm wondering why we have a separate array here. Okay, that's right. These are the ones that we're going to fill in. So we're not touching TDA yet. So I is less than byte.length. Excuse me, R bytes, random bytes, dot. Excuse me, okay. I is equal to 0. I is less than R bytes dot length. If I could type, it would help. R bytes dot length. I plus plus. We can't use a for each loop here because we're actually modifying the values as we go. Now I hope we have a random object already declared. I better scroll back up and check.
We do, it's R&D1.
Okay, so we made a random object called R&D1. So back down here where we have our R bytes. Each byte, R byte, oh, come on. R byte at subscript I.
It's R bytes with an S.
Excuse me, with an S.
Yeah,
I need to make my array names easier. So R bytes index I is equal to R&D1 dot next bytes. Oh, what do you know? Next bytes actually fills in a buffer. I had forgotten that. So we don't need to loop through it. We need to just call random.nextBytes and let it fill in the buffer with random values. Let's do that instead. Delete all that for loop stuff. And we're going to call rnd1.nextBytes and pass in our rbytes array. Now this doesn't seem like enough to me because we actually haven't filled in our text boxes. We've only generated an array of bytes. Let's go look at our text boxes again. Here they are. What are they called? If I could see my properties, it'd be a lot easier, but I could look down in the XML. This is just text box 1, text box 2, text box 3, text box 4, and text box 5. Alright, I had to pause for a moment. Let's store the value of each text box, which we confirmed were just the values text box 1, text box 2, text box 3, text box 4, and text box 5. We've generated 5 random numbers. We could have generated them one at a time, but anyways, text box 1 dot txt is equal to, and we need to get our bytes 0, like that. Now, if this looks primitive, and it should be our byte 0 dot toString, because text box requires string data. Dot toString. Surely I don't have to provide a format. There we go. I had a lowercase t rather than an uppercase t, following Java conventions. Alright, and then I just need to replace that with text box 2, 3, 4, and 5. And if you think this is a primitive way of doing it, you are right. What we should do is put these text boxes into an array so we could rip through them in the same way that we are ripping through these bytes. And since these are each just references, we could do that. We could create an array of references, point each reference to one of the text boxes. We would have to do that in the initialization code for this form. Alright, so there we go. Well, that's still not right. Text box 1 dot text is equal to our bytes 1. Excuse me. Text box 1 dot text is equal to our bytes 0 dot toString. Text box 2 is equal to our bytes 1 dot toString. Text box 3, our bytes 2. Text box 4, our bytes 3. Text box 5, our bytes 4. Let's see if our code is at a currently compilable state. There it is. So if I click randomize, it fills it with random bytes. Bytes are smallish numbers, right, between 0 and 255, assuming they are unsigned, which they are. So that's pretty neat. But if we click save, it doesn't do anything. So guess what we're going to make the save button do? It's going to save it to our two-dimensional array. And I hope that we limit our adding to the array to prevent a situation where we are trying to write past the end of the array. Alrighty. So we've done some of this. Here we have 4 values. If I was cool, I would have called them A0, 1, 2, 3, and 4, right? But instead these numbers are matching the names of the text boxes. Alright, so we have a great big try parse statement where we try to convert all of them at the same time. Good enough. And then we store these values into our input array. Why didn't we just put them right here? We could have done that, but I guess the syntax would have been nastier. Alrighty, so if I remember the name of our array, I would be dangerous. TDA, two-dimensional array. TDA could also stand for a three-dimensional array. So anyways, TDA subscript 0 is equal to A1. A1 being the value that we ripped out of text box 1. Why didn't we just try that right on the, right from the get-go? We could have put the try parse right here, but that would be bad because it would make the logic for checking to see if the conversions worked a little bit more complicated. You'd have a whole bunch of if statements.
It's a two-dimensional array, don't you have to
Yep.
give it another position?
So we need to give it a row number and then a column number. So our row number we declared way up here, although we gave it the silly name of index. Nope, we're actually filling these into int array. Excuse me. We declared an int array of 5. So, did we not? No, I'm not seeing where we did that. Instructions are slightly off. We got to declare our int array. So we may as well do that. Int, square brackets, IA is equal to new int. And I guess we are hard coding. 5 is the length of our, the number of columns in our array. So, all right, so we declared our int array. Now let's copy each value into it in turn. IA subscript 0 is equal to A1. IA1 is equal to subscript A2. IA2 is equal to subscript A3. IA3 is equal to subscript A4. And IA4 is equal to I don't know why I'm saying subscript over and over and over. IA subscript 0 is equal to A1. IA subscript 1 is equal to A2. IA subscript 2 is equal to A3. IA subscript 3 is equal to A4. IA subscript 4 is equal to A5. Alright, so we've done that one. But that didn't change the display, so I'm not going to compile and run it. Well, I guess I can compile and make sure I don't have any syntax errors. Doesn't look like I do. Now add our values to the big array. So first we need to calculate the length of the array in row and columns, then copy the elements of IA array into TDA. Don't forget to make sure that the index is less than the max number of rows. Alright, so I guess we're pretending we don't know the number of rows and columns. So why don't we just declare two variables? Rows is equal to TDA dot get length. And if you recall, the way we call get length is if we want the number of rows, we pass in 0. If we want the number of columns, we pass in 1. If you're using a three-dimensional array, you could pass in 2, and so on. So int calls is equal to TDA dot get length 1. That's kind of a neat way to handle it, actually. I'm making contrast to that and the arrays in Java when I say that. We have to do something a little bit different. All right. Now copy the elements of IA into TDA. Don't forget to make sure that the index is less than the max number of rows. So we have a variable that we declared index way up there that we never used. All right. So if index is greater than or equal to our number of rows, then we're out of luck. We need to not do anything else. We could display an error message, I'm going to leave that blank for now until I decide what I want it to do. You know what? In that case, I could reword it, huh? If index is less than the number of rows, then we're golden. So let's copy our values into it. I keep itching to use a for loop to copy values. We can do it here. I love that everywhere else, we've hard-coded, 5, elements 1, 2, 3, 4, and 5, and here all of a sudden we're pretending we don't know the size of the array, but that is actually the better thing to do. So, for how many columns are there? Well, it's equal from 0 up to calls minus 1, right? So int C for column is equal to 0. C is less than the number of calls, C++, and in our two-dimensional array, at row subscript index, right? TDA, I guess I could zoom in a little bit. Index comma C for our current column is equal to our input array at position C. And once we're done with all that, we want to increment our index, which is actually our row.
So should that be a while loop then? Or we have
Nah, for loop's cool.
no above
That if statement, no, because we're only iterating once.
Okay.
Yeah, so the question was, why isn't this a while loop? It looks like a while loop, right? But it's not. We are keeping track of the number of rows as our index counter, which is a variable, a member that we declared way up here. So these are actually instance members, not just local variables. So scrolling back down here, I think we're good, but then we need to update our text box at the bottom. What are we going to put there? We're going to print out our array. So we're going to iterate through all the rows and all the columns of our array as though we were printing them, except in this case we're just going to be adding them to an output string. Right? So instead of doing console.display with a nested loop, instead it's going to be output plus equals inside of our nested loop. And at the end of every row we need to put a /n. Alright, let's do that. So we need for int r is equal to 0, r is less than the length of our array, tda.getLength, subscript 0. Yeah, we already had that declared up there, but why don't we do this totally proper? Semicolon. So we have tda.getLength parentheses 0 in parentheses semicolon r plus plus. Now we need our nested loop. For int c is equal to 0. C is less than tda.getLength1. C++. And let's add that number to our output. So output plus equals string.format, just like it shows up in the comment up above. And I guess we're allocating 5 spaces. These bytes are at a maximum 3 long. So by allocating 5 spaces, we're going to have 2 columns, 2 spaces between each number. So string.format parentheses, open quote, placeholder 0, comma 5, indicating that it's going to take up 5 spaces, end quote, comma, and then our current value, which is TDA, square bracket, R comma C. Now that's iterating through all the columns in one row. So after we're done with a row, we want to tack on a /n to our output. Output plus equals \n. Then we need to set our big text box equal to this output. So I'm going to go back to my main window after I pause here for a moment more and enjoy my work. Go back to the main window. Let's get the variable that is attached to that text box. It's this one, the big one, the one that's 188 pixels tall. And his name is Textbox Output with a capital B and a capital O. Got that right there. Let's go back in here. And now that we are done with our nested loop, Textbox Output dot text, capital T, is equal to our output string.
I think it already has it at the bottom.
We already did that at the bottom? Yeah, we already did that at the bottom. Okay, fine. I'll delete that line. There we go. And then it says go back and modify the loop. But I'm really in a hurry to see this work, so I'm going to save step 8 for just a minute. So there's our code there. Pause if you need to type it in. I guess I'll scroll through this slowly at the end of it so you can correct any errors, but I hope you've been getting it right as we go along. Alrighty, start. There we go. Randomize it so we have some data. Save it, and there's our array. going to randomize again, save them, and there we go. Randomize again, save. All right, we're done. We probably ought to just, add a message to it saying that, we can't fill our array anymore. But we could use a text box for that. Where would we change that? Up previously, where we checked to make sure that our index was not greater than the number of columns. So up here, where was that? We could do that at the very beginning. Why would we care? Well, we need to do it as soon as possible, but I mean, why do we go to the bother of reading in all these text boxes using try parse if the array is already full? So the logic here is a little bit wacky. We should have gotten the number of rows and the columns at the very beginning and then checked. But anyways, so step 6b, copy the elements. Don't forget to make sure that the index is less than the maximum number of rows. So if index is less than a number of rows, great. Copy our data into our input array. Else, let's pop up a message box. Message box.show. Let's go do that. So inside of our else, message box.show, array is full. And then we'll return out. I'm going to test that change before we do the final thing, which was add the total. And the assignment only wanted us to add, put the total on the end of each row. It would be cooler if we also put the totals, of each column at the bottom like you would expect to see in Excel, but I think we're going to skip that. So there we go. Save. And then our array is full. Very good. One last thing to do down in step 8. Put a total after this stuff. So we're going to actually need that in our loop, right? Unless we declared a second text box full of totals, because we're going to write out every item in a row, and then before our /n that we appended output, we want to append the total. We can do that. So that was down here in step 8. Go back and modify the for loops to display a sum at the end of each row. Let's do that. Right here, before we do output plus equals \n inside of our nested loop, let's tack on the total. So, all right, so before our \n, we need a sum. Int sum, float sum, whatever. Int sum is equal to 0. And yes, there is an array.sum method. However, I do not believe that we can take each row separately and turn it into a single dimensional array for the purposes of calling sum like that. There may be a way to do it, but it doesn't take any time at all to write a loop that will sum up that array, that column, excuse me, that row. In fact, we could have been doing it right here, right, while we're stepping through them. Let's do that. Let's declare our sum up above our inner for loop. Int sum is equal to 0. And then before or after we output that value, let's add it to our sum. So sum plus equals TDA subscript R comma C. And then underneath that for loop, before we add \n, let's tack that on. Whoopsie, I did not mean to, okay. Fine. Why won't you dock? For Pete's sake. There. No. there. Okay. Output plus equals string dot format parentheses quote space sum equals placeholder 0 again, end placeholder comma 5. Nope, 5. Where'd I get that? Sum. There we go. Select that.
I really do love the placeholders.
You like the placeholders?
Love the placeholders.
Yes, yes, I agree. Python has borrowed this exact syntax for placeholders almost recently. Alrighty, there we go. Let's start adding numbers to it, and if I was zoomed in enough that you could see that, you would see that our sums are increasing. Alright, well and good. I guess if we want to be totally cool, we could add one more text field down at the bottom. That would be the sum total of everything that we've added to it. But I think that's enough. I think that's enough. So there was only one bug in the instructions as far as I am concerned, which is that up here I never said, where it says copy the elements, add our input values into the 2D array. Above here we had to allocate our input array in the first place, and I don't believe I ever said that. So I should modify this file so that it has that, but I'm going to leave it as is because you're going to be following the instructions along. And then if I've already made changes to it, it will be confusing. Alright, so I'm going to scroll up to the top, go down to the bottom, pause the screen as you need to. So inside our partial constructor for main window, we declared our two-dimensional array and our index, which I still think we should have called it something better than index. Row would have been a good name for it. And then down here in step 2, we actually allocated that array. We certainly could have just done this right when we declared it. There wasn't any reason to actually put that, in that constructor rather than down here where I called that the partial constructor. That was completely wrong. It's a partial class, and we were adding methods to our partial class. So anyway, step 2, TDA is equal to new int, subscript, or square brace 10, comma 5. Then for our randomized code, looked kind of primitive, but here's what we did. Declared an array called bytes, 5 length. Then we filled in that byte array with next bytes. Then we copied the bytes one by one and into text box 1, 2, 3, 4, and 5. Now save, click. Section 4 was already done. Section 5 looks like that. Declare our integer array, IA. Copy those 5 values into it. Oh, did it already say don't forget to create the array? Okay, forget all my babbling about that not being listed as a comment because it was. Section 6. Calculate the length of the array. Copy the elements of the IA array into TDA, limiting them. If our index is less than the max number of rows, we're good. Otherwise, it's a problem. So if index is less than rows, copy it in with a for loop. Else, message box.show array is full. Return. And then lastly, section 7. We want to create our output string, which we'd already allocated up here. So we keep appending to our output string with a nested for loop that looks like that. All right, hope that was interesting. Hope you got it to run. Go ahead and close your solution and zip it and upload it to the Dropbox. So, any questions, guys?
Well, that's weird.
That was weird, huh?
Well, I don't know. It's because like I already told you how I am about like I always delete everything and start from scratch. And since we just went in and filled everything, it just seemed weird because I had no clue what we were doing at first. But now
Right.
I have the idea of what we were doing.
Right. I should have had a finished version of the application to run so that you could see what it was doing before we actually started doing it, or at least explained a little bit better. At least a screenshot. That would have been nice, rather than just blindly follow. But I hope it was still educational.
Yes, it